China has just built a flying vehicle unlike anything the world has ever seen. And the most shocking part is that it is not a prototype sitting in a laboratory. It is already in mass production, already taking pre-orders, and already carrying paying passengers above Chinese cities right now. While the rest of the world is still debating whether personal flight is even possible, China has crossed 3 milestones simultaneously that no other nation has managed to reach even once. A government-certified pilotless air taxi already flying commercial routes, a 6-wheeled truck that deploys a personal aircraft from its cargo bay at the press of one button, and the world's first flying car factory producing one aircraft every 30 minutes. In this video, you will discover the 8 most advanced personal flying vehicles China has built, certified, or begun mass producing in 2026. Stay until the end, because the final vehicle on this list represents something that no manufacturer in America, Europe, or Japan has come close to matching. Now, let us begin. At number 8, with a vehicle that crossed a threshold that no flying machine had ever crossed before. The EHang EH216-S. In October 2023, this aircraft became the world's first pilotless passenger-carrying drone to receive an official type certificate from a national aviation authority, specifically China's CAAC, the regulatory equivalent of America's FAA. That certification alone would have been a landmark, but the story did not stop there. In March 2025, 2 Chinese operating companies received the world's first operational certificates for autonomous passenger drones, clearing the EH216-S to begin carrying paying customers on commercial routes. Right now, as you watch this video, tourists are purchasing tickets to take low-altitude aerial tours above Chinese cities in a vehicle with no pilot on board, no flight controls inside the cabin, and no human physically managing the aircraft. You simply select your destination on a touchscreen, and an AI-managed ground control center handles everything else. The EH216-S carries 2 passengers using 16 independent rotors across 8 folding arms, with each rotor system independently redundant, meaning the aircraft continues safe flight even if multiple motors fail simultaneously. What makes this even more significant from an analytical standpoint is the regulatory gap it reveals. In the United States, the FAA has not yet certified a single pilotless passenger-carrying aircraft for commercial operations. In China, they have already moved past certification into commercial ticketed flights, with operational centers in Guangzhou, Hefei, and expanding across dozens of additional cities. The management architecture being built around these routes is laying the precise coordination infrastructure that will eventually handle thousands of autonomous aircraft above every major Chinese urban center. Moving forward with our countdown, we arrive at number 7, a vehicle that proves personal electric flight does not require wealth, a runway, or a pilot's license. The Jetson 1. This ultralight flying vehicle weighs only 86 kilograms and is powered by 8 electric motors producing 88 kilowatts of combined thrust. Under FAA ultralight regulations, it requires no pilot's license to fly in the United States. The entire onboard computer system is built around one commitment. If the pilot releases all controls, the aircraft returns to a stable hover automatically. It cannot stall. The flight computer will not allow the machine to enter a condition from which it cannot recover. What the Jetson 1 establishes is an important benchmark, proof that the engineering challenge of safe personal flight has been solved at the consumer level. However, as an analyst looking at the broader manufacturing picture, the critical distinction between what Jetson represents and what China is building is one of scale. Jetson is a small Swedish team producing hundreds of aircraft per year. The next vehicle on this list is a Chinese manufacturer building the production infrastructure to produce hundreds of thousands. Now, I know some of you may be skeptical about whether any of these vehicles can survive a critical failure at altitude. Stay with me, because number 6 addresses that question directly, with an answer built from 200 sensors and a processing speed measured in milliseconds. The Volant Aerotech VE25-100, from Shanghai-based Volant Aerotech. While the Jetson 1 proves personal flight is possible at the consumer level, the VE25-100 represents what happens when China's industrial manufacturing capability is pointed at the same engineering challenge. This vehicle is designed to accommodate 1 pilot and 5 passengers, with a maximum cruise speed of 235 kilometers per hour and a range of 200 to 400 kilometers. Its distributed electric propulsion system delivers continuous micro-adjustments across every motor independently, meaning the aircraft monitors and corrects its own flight envelope faster than any human input can achieve. Every phase of flight is processed through redundant flight control systems that evaluate structural load, battery state, airspace conditions, and propulsion health simultaneously in real time. The VE25-100 does not merely fly, it calculates. However, the most strategically important detail about the VE25-100 is not its propulsion architecture. It is that Volant Aerotech has already signed confirmed orders with China Southern Airlines General Aviation, believed to be the first confirmed orders for a commercial passenger eVTOL anywhere in the world, backed by a total order pipeline valued at over 3 billion yuan. While Western eVTOL startups are raising Series B funding rounds to build their first 10 prototypes, Volant completed its first production batch aircraft roll-off in 2025 with continuous breakthroughs in test flights, attracting concentrated investment from 5 listed companies simultaneously. The engineering gap between East and West in personal aviation is not primarily a gap in ideas. It is a gap in production infrastructure that took China 2 decades and a complete domestic EV revolution to build. The Autoflight Prosperity. This Shanghai-developed passenger aircraft recently set a verified world record for the longest flight ever completed by an electric vertical takeoff and landing vehicle, 155 miles on a single charge. That figure matters not because 155 miles is a remarkable distance, but because it crosses into the territory where an air taxi stops competing with cars and starts competing with short-haul flights. Autoflight's prosperity can now replace regional aircraft for journeys between cities that currently require a 45-minute airport security process for a 30-minute flight. The safety architecture reflects the engineering philosophy that at altitude there is zero margin for component failure. The aircraft integrates automated ballistic parachute deployment capable of engaging within 0.3 seconds of a critical failure, multi-sensor collision avoidance using LiDAR and radar simultaneously, and an AI flight management system that executes a controlled emergency landing without any pilot input. The aircraft can save itself even if the human aboard panics and does nothing. This emphasis on autonomous safety redundancy is precisely what will convince the mass market to trust this technology for daily commutes, not just adventure tourism. As we look at the Prosperity alongside the EH216-S, it raises a very interesting question about how personal aviation enters mainstream daily life. Would you feel more comfortable as a passenger in a fully autonomous AI-managed system? Or would you want manual override capability as a co-pilot? What are your thoughts on this critical design choice? Let us know your opinions in the comment section below. At number 4, we encounter the vehicle that has done something no other manufacturer on Earth has managed to do in 50 years of trying. The XPeng Aero HT land aircraft carrier. This is not a flying car. That framing understates what it actually is. It is a modular transportation system that dissolves the engineering contradiction that has defeated every flying car concept for the past 5 decades. The contradiction is fundamental. A vehicle optimized for road driving performs terribly in flight, and a vehicle optimized for flight performs terribly on roads. Every team that tried to build one vehicle that does both ended up with something that does neither well. XPeng's engineers chose a different solution entirely. The land aircraft carrier is a 6-wheeled, extended-range electric mothership. Road legal, 5.5 meters long, fits a standard parking space, requires only a regular driver's license. Inside its rear cargo bay sits a completely separate 2-seat electric aircraft. When you reach the edge of the city, the aircraft deploys from the mothership automatically through a single-button sequence. The mothership stays on the ground. You fly in the aircraft. When the flight ends, the aircraft docks back into the mothership and recharges during the road portion of the return journey. Each system is perfectly optimized for its own environment. They never compete because they never try to perform the same function simultaneously. As of November 2025, XPeng's Guangzhou factory, covering 120,000 square meters, had already completed the world's first trial production aircraft off the world's first mass production flying car assembly line. The company has secured approximately 5,000 pre-orders at up to 2 million yuan, approximately $280,000 US. Mass production is targeted for the second half of 2026, with annual capacity of 10,000 units, a figure that would exceed the combined total output of every other eVTOL manufacturer on Earth. While European competitors like Volocopter have spent years navigating funding crises and certification delays, XPeng has already broken ground, built the factory, rolled the first aircraft off the line, and started collecting customer deposits. The manufacturing gap between Chinese and Western eVTOL development is no longer measured in technology. It is measured in production infrastructure that simply does not yet exist anywhere else in the world. At number 3, we step back from individual vehicles and look at something that most analysts covering flying cars completely overlook. And it may be the most important competitive advantage of all: the operational ecosystem China is building around these vehicles. Because the aircraft themselves are only part of the story. What China is constructing alongside them is the infrastructure layer that has always been the fatal missing component in every other country's aerial mobility vision. Since March 2025, the CAAC has been deploying low-altitude operational management centers in Guangzhou, Hefei, and expanding to dozens of additional cities. These are not theoretical platforms. They are active, staffed, and already managing real commercial flight hours. The 89,000 enterprises currently registered in China's low-altitude economy, a number that grew 220% year-on-year in just the first 5 months of 2025, are not all building aircraft. Many are building vertiport ground infrastructure, air traffic coordination platforms, maintenance networks, and the digital airspace management systems that turn individual flying vehicles into a coherent transportation layer above the city. Roland Berger projects 100,000 air taxis in global operation by 2050. But the critical analytical insight is that China is not simply building the vehicles. It is simultaneously constructing the regulatory framework, the digital infrastructure, the operational expertise, and the consumer familiarity that a functioning urban air mobility ecosystem requires. By the time Western regulators finish drafting the rules, China will have a decade of real operational flight data. The country that controls the operational data of urban air mobility will shape the global safety standards and certification benchmarks for the next 30 years. China is building that data lead right now. This brings us directly to number 2, where the next generation of Chinese autonomous aviation is already being designed, even as the current generation is still being deployed. China's next-generation autonomous aircraft architecture and what it signals about the direction of this entire industry. EHang is not standing still with the EH216-S. The company is developing larger-capacity autonomous vehicles targeting medical emergency transport, intercity routes, and high-volume cargo operations. A new all-electric platform with a maximum takeoff weight of 3,180 kilograms and a range extending up to 300 kilometers has already passed initial flight tests in China, designed for medical rescue missions and urban air mobility at scales that 2-passenger aircraft cannot reach. The pattern across all of these vehicles reveals something that Western aviation executives are only beginning to process. China's approach to personal aviation does not follow the Western model of a small, innovative startup pioneering a technology that a legacy manufacturer later acquires and scales. China's model is to build the regulatory permission, the manufacturing infrastructure, and the market adoption ecosystem simultaneously, using state-backed investment to compress a development timeline that would take Western competitors 15 to 20 years into a window of 5 to 7. While American policymakers continue debating the regulatory classification of autonomous passenger vehicles, Chinese operators are already logging commercial flight hours and generating the operational safety data that will define global certification standards. The race for personal aviation dominance was never primarily about the vehicles. It was always about who controls the operational ecosystem those vehicles fly inside. And that ecosystem is being built right now, at speed, in China. Finally, we reach the absolute pinnacle of our countdown. Not a single vehicle, but the moment this entire trajectory has been building toward, and why it matters. For decades, every civilization that has imagined personal flight has pictured one thing: a vehicle you drive to work and fly home in. That vision always collapsed against the same engineering reality. You cannot optimize one machine for 2 completely different performance envelopes. XPeng did not solve that engineering problem. They made it irrelevant. The land aircraft carrier asks you to accept something more practical than a fantasy. A system where the ground portion and the air portion are each perfectly optimized for their own environment, and where the transition takes less than 60 seconds and requires no specialized skill. One button. The 5,000 buyers who have already placed $280,000 orders are not buying a novelty. They are buying a system. The 120,000 square meter factory in Guangzhou, producing one aircraft every 30 minutes at peak capacity, is not running a prototype batch. It is building a supply chain. As we look at the entire landscape of personal aviation in 2026, what is unfolding in China is the convergence of 3 things that have never previously existed simultaneously in the same country: the regulatory permission to fly autonomously, the manufacturing scale to produce these vehicles at pricing that approaches consumer accessibility, and the operational infrastructure to manage thousands of them safely in shared urban airspace. We are not waiting for the future of personal flight anymore. In China, the future has already gone into mass production. The sky above Chinese cities is no longer empty air. It is becoming a highway. Now that we have covered all 8 vehicles reshaping the future of human mobility, I want to hear your final thoughts. Which do you believe will reach mainstream adoption first? The fully autonomous passenger drone or the modular land and air system? Please share your detailed insights in the comments below. If you found value in this analytical deep dive, do not forget to hit the like button, subscribe to the channel, and share this with someone who still thinks flying cars are science fiction. We will see you in the next analysis.